Hello everyone, I am NAVEEN Kumar. In this video, we are going to explain how arithmetic operations are performed using unsigned integers in MATLAB. So, we implement operations like addition, subtraction, multiplication, and division using different bit widths such as 8-bit and 16. This helps us understand overflow, underflow, error handling, and memory usage in low-level arithmetic. Come, let's go into the video. So this is our first question. So here this is a sample code. Yeah, this is our first question. So here modify the given MATLAB program to support 32-bit unsigned integer addition and display the result among all the memory usage. Okay. Okay, this code goes like in this program we perform addition using 32-bit unsigned integer in MATLAB and also calculate the memory usage. So first CLC at the top of the code clears the command window and removes all existing variables to avoid conflicts. Next, the program asks the user to enter two integer values using input function and stores them in a variable a and b. These input values are then converted to 32-bit unsigned integers using the unit32 data type and stored as a val and b val. The addition is performed using sum underscore val variable, which is equal to operation value a variable plus b variable, which ensures the calculation follows 32-bit unsigned arithmetic. The result is displayed using fprintf, where percentage is used to print an unsigned integer. Okay, now we have to check the overflow. Get there. To check for overflow, the inputs are converted back to double and compared with the maximum value of 32-bit unsigned integer, which is 4294967295. If the sum exceeds this limit, the program displays overflow occurred. Otherwise, it shows no overflow. Finally, this program demonstrates how MATLAB handles 32-bit arithmetic overflow detection and memory usage analyzation. Now let's see one test case. So first we have to enter the first integer value, which is 100, second integer value 200, and 32-bit result is 300. Okay, no overflow in 32-bit arithmetic. So let's see some overflow example. Yeah, so here we have entered the value like some 4 zeros and second integer values from 5 zeros. So 32-bit results exceeds the value which I have said before. So overflow occurred in 32-bit arithmetic. That's all. Okay, and now we will go for second question. Okay, here change the given program to perform subtraction of two unsigned integers. User selected with here the user have to select the bit width 16 or 8, sorry, and direct underflow. Okay, now let's dive into the code. Okay, so in this program we perform subtraction of two unsigned integers using user selected bit width either 8-bit or 16-bit and direct underflow. First, as we say, CLC clears the command window and clear removes the previously stored variables. This is the inbuilt function. The program that then asks the user to enter the two integer values which are stored in variable a and b. Next, the user selects the bit width by entering 8 or 16, which is stored in a variable choice. So we are here with choice, which is 8 and 16. So if the user select 8-bit, the input values are converted to unit 8 data type and subtraction is performed using the operation diff underscore variable equal to variable a minus variable b, and which is printed using printf fprintf. So now we are here to check the condition and displays whether underflow is occurred in 8-bit arithmetic. Similarly, if the user selects 16-bit, the inputs are converted into unit 6, subtraction is performed and the result is displayed. And underflow is checked. Oh, the underflow check is again done by comparing original to input values. Then, whose command is used to calculate the memory usage. Oh, yeah, yeah. Here's the whose command. Whose command is used to calculate the memory usage, as I said. An 18-bit integer uses 1 byte, while a 16-bit integer uses 2 bytes. The total memory usage is displayed. If the user enters an invalid bit with, the program displays an error message. This program helps us to understand unsigned subtraction, underflow behavior, bit width selection, and memory usage in MATLAB. So let's see some test cases. So here we have given two integers, which is 250, and we have to choose the option for bit. So here we have chosen 8. So the 8-bit result is equal to 150. So no overflows occurred because the condition is true. Yeah, here the first integer value is 10,000 and second one is 20,000. So here we have given 16. So here 16-bit result is equal to 0 because in subtraction we have to subtract greater number by smaller number. So underflow occurred in 18-bit. Okay, now let's go into third one. Here we are going to multiply the unsigned integers using 8-bit or 16-bit arithmetic and check for overflow. Okay. Okay, in this program, in this third one, we have performed multiplication of two unsigned integers. Okay. As the above two codes, we have to enter the CLC, which clears the command window, and clear removes all existing variables. The program then asks the user to enter two integer values, which are stored in variables A and B. Next, the user selects the required bit width by entering 8 or 16, which is stored in the variable choice. So, if the user selects 8-bit, the input values are converted to unit 8 data type, and multiplication is performed using product. The equation goes like variable A multiplied by variable B. Okay, the 8-bit multiplication result is displayed since the maximum value of an 8-bit unsigned integer is 255. The program checks whether the actual product exceeds the limit. So this is the main condition. If the limit is exceeded, the program displays overflow occurred 8-bit arithmetic. Otherwise, it shows no overflow. If the user selects 16-bit, the input is converted to as like unit 8, it converts into unit 16, and the multiplication is performed. In 16-bit arithmetic, the maximum unsigned value is 65535, and the program checks overflow using this limit. Finally, again the whose command is here. The whose command is used to calculate memory usage. An 8-bit integer uses 1 byte, while 16-bit uses 2 byte, and the total memory usage is displayed. If any invalid bit is selected, the program displays an error. So here, see. Yeah, here we have given the multiplication thing. Let's see some test cases. 8-bit multiplication with no overflow. First enter the value 10, 20, bit width of 8. Okay, the result becomes 200. Here no overflows occur because in 8 it should go like it should not go above 255. So let's see some overflow at 200 into 300, 16-bit. No overflow occurs because for 16-bit the limit is like 35535, 65535. Sorry. Okay, that's all. Come, let's go to a fourth one. Write a MATLAB program to subtract two unsigned integers. Display result using 8-bit or 16-bit arithmetic. This one is like same other one. Which is second, I think so. Yeah, this is the last one, fifth one. Write a MATLAB program to divide two unsigned integers using 8-bit and 16-bit arithmetic. Handle division by 0 condition. Okay, let's dive into the code. As this is CLC clear, which is to clear command, and this clear is to clear all existing variables which are a and b. So inputs, we are getting inputs, we are getting the choice whether it is a 8-bit or 16-bit. Now here's the condition. In this program, yeah, we are going to divide a two unsigned integer. So the program then asks the user to enter the numerator and denominator values. Next, the user selects the required bit with the choose thing, either 8-bit or 16. Before performing division, the program checks whether the denominator is 0. If it is 0, an error message is displayed. So here, if b is equal to 0, which means the denominator which is equal to 0, we have to display that division by 0 is not allowed. Okay, and then else we are going to give the main condition. If the denominator is valid, the 8-bit is selected, the inputs are converted to init 8 and division is performed. As like this for the same 16-bit. The result displayed and memory usage is calculated using use command. Yeah, here. Use command where each 8-bit value occupies 1 byte. Similarly, 16 is selected, the inputs are converted to init 6, division is performed, and memory usage is calculated when each value occupies 2 bytes. If an invalid bit is entered, the program displays an error message. So, as in end, the program demonstrates unsigned division, error handling, bit width selection, and memory usage analysis in MATLAB. Okay, let's see the test case for division thing. Yeah. Okay, in this video we have covered the addition, subtraction, and the multiplication and division in MATLAB performed by using unsigned integers. So thank you.